Okay, today we will look at another example of how to apply a rotating axis, and let's call this example 3. Example 3. In this example, you have a crank slider mechanism, and which is an IC engine with a piston, connecting rod, and a crank, and the distance, and let's put the point here as A, B, C, and the length AC is 400. AB is 300, and it has a angular velocity of 10 radian per second, angular acceleration of 20 radian per second square. And the question asks you, using a rotating axis XY with the origin at A and the x-axis is in the AB direction, determine VC and AC. So the question asks us to find the acceleration of the piston and also the velocity of the piston. So the first thing for us to do is to draw the rotating axis, which is here. This is Y and this is X. It's given to us. Okay, and then from there we can write the velocity equation and the angular acceleration equation. So let's solve this slowly. So let's write the equation. So VA equals to, or VB equals to VA plus omega cos R plus V relative, and then we have the acceleration equation. AB equals to A plus omega cos R alpha cos R to omega cos V relative. There are 5 terms here, 1, 2, 3, 4, 5. So find the value of each term. Okay, so here we are going to relate this with this rotating equation. Remember, this is our big capital X, capital Y, and we have a small x, small y, and the origin here is A, and this is B. Yes, and this is our R, and A and B are rotating with omega and alpha, and this is O. Yeah, so because our A, since A is pivoted, not translating, therefore VA equals to 0 and acceleration of A equals to 0. So then we need to find what is R here. So we can see that what is the link. We can know that the point C here is equivalent to the point B here, point A here is equivalent to point E here. So these are the relationship that we are going to make when we use the equations in the above. Yeah, so VA equals to 0 and acceleration of A equals to 0. And what is R? What is R? R from here is point C is above point A, so point C is, this is B relative to A, is 400 J mm. Yeah, and what else do we need? Do we know what omega is? Omega is XY, so omega is 10K, and we know alpha is 20K. This is radian per second, this is radian per second square. Do we know what V relative is? V relative is how fast is this thing moving to A we do not know what V relative is. So, but is there a limit of what VC is? Well, we know that VC is only moving in the I direction. So if we write this thing, we know what VA is. This is 0. Do we know what V relative is? We do not know how fast it is moving relative, but we know what omega is. This is 10k. We know what R is. R is 400J. V relative, we don't know what V relative is. Do we know what VB is? Yes. VB in this case is VC equals to VC, and VC in this case, it only can move in the Y direction, so we can put that at VCJ. So if we write this equation again, we will write that as VCJ equals to 0 plus 10k, 0 plus 10k cross R 400J plus V relative. Yeah, so this is equals to VCJ. K cross J is minus I, so this is 4000I plus V relative. V relative. And what is V relative? Okay, in this case we cannot find V relative directly, so we need to solve first this VC. This is given in terms of the global coordinate system VC. Therefore, because they are coincident anyway, VC is measured from the global coordinate system. So we know that VC equals to VC relative to A, and therefore this is equal to VC relative to B plus VB relative to A. These are using the XY system. So VC relative to B can be obtained from omega BC cross position vector C relative to B, and VB relative to A is omega AB cross position vector B relative to A. And this one we know to be 10k. Cross position vector B relative to A is 300I, so k cross I is J, so this is 3000 J millimeter per second, and this is the vector for B relative to A. Now we need to solve the other part, which is VC less than omega VC. We do not know that, but we just represent that by K, and position vector C relative to B, C relative to B is 400 to the top and 300 to the left, so it's minus 300I plus 400J. Yeah, so K cross I is J, so minus 300 omega BC K cross I is J. K cross J is minus I, minus 400 omega BC I. So that is velocity C relative to B. So we got these two answers, and therefore we can write VC equals to VC relative to B minus 300 omega BCJ minus 400 omega BCI plus B relative to A plus 3000 J. So that is equivalent to minus 300 omega BC plus 3000 J minus 400 omega VC I, and that's your VC. This is omega VC, yeah. So then we can find the V relative. So we'll now put back to this top equation here. Bring the top equation here. So VC relative to J, VC is, we'll put the VC here. So VC equals to minus 300 omega VC plus 3000 J minus 400 omega BCI know that VC equals to VCJ. Therefore, looking at J part or looking at I part, we know that minus 400 omega BC I equals to 0. This is 0, yeah? Yeah, therefore omega BC equals to 0, and according to J part we have got then VC equals to VCJ, then VC equals to minus 300 omega BC plus 3000, and this is 0, therefore VC equals to 3000, and that unit is millimeter. So that's the answer for VC. So what was key to us was that we know that VC has only J component, because the piston can only move up and down, and this allows us to find the proof that omega BC equals to 0. At this particular point, omega BC equals to 0. It does not have an angular velocity, and therefore we can find the solution of VC equals to 3000 millimeter per second. So VC equals to, the vector representation is VC equals to 3000 J millimeter per second. So that will be the answer. Okay, so answer. So now we can move on to the acceleration. So we look at the acceleration now. Look back at the equation here. What are the things that we do not know? So again, we can use the same approach, where we know the value of omega R, and alpha we know, but V relative, we have a V relative. Oh, we need to find a V relative. So let's find a V relative. So in this case, VC equals to 3000 J. So 3000 J equals to minus 4000 I plus V relative. So now we have a V relative of 3000 J plus 4000 I millimeter per second. So we can now, so that's our V relative. So we can use this relative in this part of the equation. We need to find the same way A, B, and A relative. So let's try to do this next. So initially, when we write this equation, and we write these two equations, this equation that most of you would have memorized is referring to this system that we derive the equation. So we now need to rewrite the equation for acceleration using our new term. So now the new equation is AC, which is the acceleration of C, equivalent to AA, which is here, plus omega cross R, yeah, plus alpha cross R plus 2 omega cross V relative plus A relative. Yeah, so this is equation. This equation, I cover this in red, refer to this condition. Yeah, so I'm running out of space of paper, so let me change to fresh paper. And we know from the initial, as we have done before, which AC is in the same direction generally, in the y or negative y direction. It's restricted to move in the vertical direction. So we can replace AC with the magnitude and the direction of J. We can assume that. Oh my god. Now we can replace, this is the equation, we can replace AC, the vector of acceleration of AC, in the, because AC is related, piston is restricted to move in the vertical direction, so we can represent AC with ACJ. That one we know. So excuse me, so we know what AA is. This one is basically 0 because point A is not moving, it's not translating anyway. We know what omega is, 10k. This is 10k. Yeah, both of them are 10k. We know what R is given here is 400J. Yeah, we know what alpha is. Alpha is given 20k. You know what R is. R is given 400J. And you know what omega is. Omega is 10k. We know what V relative is. We have calculated V relative, and that is 3000J minus 4000I. And what we don't know is A relative. This one we really do not have any. For the time being, we do not have something that is. So whatever, we have two unknowns here, A relative and AC, and we have to find ways to do it. So if you look back how we solve it, we cannot solve A relative directly. We need to find, but we know how to calculate AC, and we calculate AC using the relative, because AC is measured via X, Y, Z, i.e. the global coordinate system. So we can say that acceleration AC is relative to A is fixed, so fixed is equivalent to AC relative to B plus B relative to A. And both now we have to, because even then this is already know, we know that this is to be ACJ. Yeah, so then we have to find ACBU. The C relative to B is, they have got two components here. So we've got the AC relative to B in the normal component plus AC relative to B in the tangential component. So the normal component is because it's rotating, so we have omega minus omega BC square cross position vector C relative to B, and then the tangential component is alpha CB cross position vector C relative to B. And somehow we are quite lucky because omega BC, we have calculated this to be 0 before. So we only need to find alpha CB cross position vector C relative to B. And then, so we can bring the results here. So we can say that A acceleration of CB in the tangential direction, ACB is only alpha CB cross position vector C relative to B, and we know what C relative to B, and we can assume this to be alpha CBK cross position vector. This is minus 300 plus 400, so minus 300I plus 400j. That will give us k cross I minus j, so minus 300 alpha CB j, k cross I j, and k cross j is minus I, so minus 400 alpha CBI. So that is the position vector, acceleration c relative to b, and then we have to find b relative to a. So b relative to a, b relative to a has two components, the minus omega square b relative to a plus alpha ab cross b relative to a. Yeah, this is the normal, this is the tangent. So omega is given, it's 10, so minus 10 square. Position b relative to a is 300i. Okay, alpha AB is given as 20k, so 20k. B relative to a is minus positive 300i. So this is minus 30,000 I. Yeah. K cross I is j. This is 6,000. 6,000 j. So if we rewrite back the equation for AC j, I'm bypassing straight, taking AC j, yeah, equals to AC relative to B, so minus 300 alpha CBJ minus 400 alpha CBI plus this, yeah, minus 330,000 I plus 6,000 J. Because we have only the J component, we can forget. So if you look at I, is 0 here, so 0 equals to minus 400 alpha CB minus 30,000. Therefore alpha CB equals to 30,000 divided by 400. So that is 300 over 4. That's alpha CB. Yeah, alpha CB, or minus. So yeah, alpha CB, so it's minus 304. So that is the angular acceleration of alpha CB. It's not 0. Okay, so the vector is alpha CB, vector is minus 300 over 4. Okay, radian per second square. Yeah, so that's now we need to find what we've solved AC, and therefore take the J parts, and we can find AC equals to minus 300 alpha CB plus 6,000. Yeah, this one plus 6,000, and we know that this is minus 300. Alpha CB is minus 300 over 4 plus 6,000. Yeah, so that gives us 9, 4 zeros here, divided by 4, 6,000. So that's your AC. So you can put a vector there. Okay. So at this point, K is moving outward. This is the value. You can use calculator to find the value. So we have solved the acceleration for C. Okay. So I hope the students can do that. Understand and follow the argument how we use the rotating axis to solve this. We can double check this by using the relative position axis. Thank you very much.